Hi, good morning everyone. I am SrinivasAluvala, working as Assistant Professor in the Department of Computer Science and Engineering, SREngineeringCollege, Warangal, India. I am here to give an introduction to data communication and computer networks. Firstly, let us know the course objectives. Describes the various components and data communication in computer networking, understanding what is computer network, differentiate between different types of computer networks, understanding the data flow, and compare the different network topologies. At the end of the course, the outcomes are: student understands what is data communication and networking, knows the components of data communication, understand and identify different types of network topologies. Now comes to the data communications and computer networks. Today, in modern day of technological advancement, data communication and networking are changing the way we do things and way we live. Decisions have to be made more quickly and decision makers require immediate access to accurate information. Why wait for a week for that report to come from somewhere else by mail, when it could happen almost instantaneously through computer networks? Before we know what is data communication, let us know first what is data and information. Data refers to information presented in whatever way is agreed upon by the parties creating and by using the data. As data communication is a process of exchanging data or information. In case of computer networks, the exchange is done between two devices over a transmission media. This process involves a communication system which is made up of hardware and software. The hardware part involves the sender and receiver devices and the intermediate devices through which data passes. The software part involves certain rules which specify what is to be communicated, how it is to be communicated, and when it is to be communicated. And it is also called as a protocol. And before we see how the data communication is made over the networks, let us know the fundamental characteristics of the data communication. The effectiveness of data communication system depend upon four fundamental characteristics. They are delivery, accuracy, timeliness, and jitter. Delivery refers to the data to be delivered to a correct destination and the correct user. Accuracy: the communication system should deliver the data accurately without prone to data errors during the transmission. Timeliness: audio and video has to be delivered in a timely manner without any delay. Such a data delivery is called as real-time data transmission. Jitter: it is a variation in the packet arrival. Uneven jitter may affect the timeliness of data being transmitted. A data communication system has 5 components. They are message, sender, receiver, transmission media, and the protocol. Message is the information to be communicated by the sender to the receiver. Sender is any device that is capable of sending data, that is our message. Receiver is a device that sender wants to communicate the data, is the message which receives. Okay, transmission media, it is the path by which the message travels from a sender to the receiver. It can be wired or wireless and may subtypes in both. A protocol: it is an agreed upon set of rules used by the sender and receiver to communicate data. A protocol is a set of rules that governs data communication. A protocol is necessity in data communication, without which the communicating entities are like two persons trying to talk to each other in different language without knowing the other language. And when we move on to the data communications, firstly we need to know how two devices communicate with each other by sending and receiving the data. The data can flow between two devices in one of the following ways. They are simplex, half duplex, and full duplex. In a simplex, communication is unidirectional. Only one of the devices sends the data and the other one only receives the data. Example: a CPU sending data while a monitor only receives the data. In the half duplex communication, both the stations can transmit as well as receive, but not at the same time. When one device is setting, other can only receive and vice versa. Example: a walkie-talkie. In a full duplex communication, both stations can transmit and receive at the same time. Example: our mobile phones. When we move on to the networks, a computer network is a collection of nodes, a set of devices connected by communication links. A node can be a computer, printer, or any other device capable of sending or receiving data generated by the other. Computer networks are used for data communications. Communicator nodes have to be connected by communication links. And when we move on to the data communication and computer networks, firstly we need to know the physical structures, how the end devices or the two devices have connected to each other for the processing of data communication among the two. Before discussing networks, we need to define some network attributes. They are type of connections. A network is two or more devices connected through links. A link is a communications path that transfers data from one device to another device. For communication to occur, two devices must be connected in some way to the same link at the same time. There are two possible types of connections, point-to-point and multi-point. A point-to-point connection provides a dedicated link between two devices. The entire capacity of the link is reserved for transmission between those two devices. Most point-to-point connections use an actual length of the wire or cable to connect to the two ends, but options such as microwave or satellite links are also possible. Example: when you change television channels by infrared remote control, you are establishing a point-to-point connection between the remote control and the television's control system. Coming to the multi-point, it is a connection in which more than two specific devices share a single link. In multi-point environment, the capacity of the channel is shared either spatially or temporally. If the several devices can use the link simultaneously, it is a spatially shared connection. If users must take turns, it is a time-shared connection. Now moving to the data communications. Yes, the term physical topology refers to the way in which network is laid out physically. How one or more devices connect to a link. Two or more links form a topology. The topology of a network is a geometric representation in the relationship of all the links and linking devices to one another. There are four basic topologies. They are mesh, star, bus, and ring. Now first let us look at this mesh topology. In a mesh topology, every device has a dedicated point-to-point link to every other device. The term dedicated means that the link carries traffic only between the two devices it connects. A mesh offers several advantages over other network topologies. Use of dedicated links guarantees that each connection can carry its own data load, thus eliminating the traffic problems. Secondly, a mesh topology is robust. If one link becomes unusable, it doesn't affect the entire system. Third is the advantage of privacy or security. When every message travels along a dedicated line, only the intended recipients can see it. Physical boundaries prevent other users from gaining access to messages. The main disadvantage of the mesh are related to amount of cabling and the number of input-output ports required. First, because every device must be connected to every other device, installation and reconnection are difficult and impractical in real time. Now let us see a star topology. In a star topology, each device has a dedicated point-to-point link only to a central controller, usually called as a hub. The devices are not directly linked to one another, hence a mesh topology. Unlike a mesh topology, a star topology doesn't allow direct traffic between two devices. The controller acts as an exchange. If one device wants to send data to the another, it sends the data to the controller, which then relays the data to the another connected device. A star topology is less expensive than a mesh topology. In star topology, each device needs only one link and one input-output port to get it connected to any other device. Other advantages include robustness. If one link fails, it doesn't affect the entire system. All other links remain active. This factor also lends itself to easy fault identification and isolation. As long as the hub is working, it can be used to monitor link problems. One big disadvantage of a star topology is the dependency of the whole topology on a single point, the hub. If hub goes down, the whole system is dead. Now let us see the bus topology. A bus topology, on the other hand, is a multi-point topology in which one long cable acts as a backbone to link all the devices in a network. Nodes are connected to the bus cable by drop lines and taps. A drop line is a connection running between the device and the main cable. A tap is a connector that either splices into the main cable or punctures the sheathing of the cable to create a contact with the metallic core. Advantages for bus topology include ease of installation. Backbone cable can be laid along the most efficient path and connected to the nodes by drop lines of various lengths. In this way, a bus uses less cabling than a mesh or star topologies. Disadvantages include reconnection and fault isolation. A bus usually is designed to optimally efficient at installation. It can therefore be difficult to add new devices. In addition, a fault or break in the bus cable stops all the transmission even between devices on the same side of the problem. Now let us move to the ring topology. In a ring topology, each device has a dedicated point-to-point connection with only the two devices on either side of it. A signal is passed along the ring in one direction from device to device until it reaches its destination. Each device in the ring incorporates a repeater. When a device receives a signal intended for another device, its repeater generates the bits and passes them along. A ring is relatively easy to install and reconfigure. To add or delete a device requires changing only two connections. However, unidirectional traffic can be a disadvantage. In a simple ring, a break in the ring can disable the entire network. This weakness can be solved by using a dual ring or a switch cable capable of closing off the break. Here is the hybrid topology where a star backbone with the 3 bus networks has been connected. In real time, the network is going to be a mixture of topologies made possible to implement a better effective communication network. Now we can go for seeing a heterogeneous network made up of 4 WANs and 2 LANs. Networks are categorized on the basis of their size. The 3 basic categories of computer networks are local area networks. Local area network is usually limited to few kilometers of area. It may be privately owned and could be a network inside an office or one of the floor of a building, or a LAN could be a network consisting of the computers in an entire building. Wide area network is made up of all networks in a geographically large area. The network in the entire state of Andhra Pradesh or Telangana could be a WAN. A metropolitan area network is of size between LAN and WAN. It is larger than LAN but smaller than WAN. It may comprise the entire network in a city like Hyderabad. The Internet. A network is a group of connected communicating devices such as computers and printers. An Internet is 2 or more networks that communicate with each other. The Internet has come a long way since the 1960s. The Internet today is not simple hierarchical structure. It is made up of many wide and local area networks joined by connecting devices and switching stations. Hierarchical organizations of the Internet. When you look at the picture here, a national ISP, Internet Service Provider, which is going to get connected to the regional ISP, Internet Service Provider, and those regional ISPs got connected to the ISPs, that is a local ISPs, Internet Service Providers, where the local ISPs goes for providing the network service to the end systems. And when you look at the picture here, national ISP, national ISP, national ISP, all connecting to a network access point, where all these they are going to get connected together to form a large network, interconnection of national ISPs. As basically a network is a group of connected communicating devices throughout the world or the globe. In this section, we define 2 widely used terms, protocol and standards. A protocol is one of the components of a data communication system. Without protocol, communication cannot occur. The sending device cannot just send data and expect the receiving device to receive and further interpret it correctly. When a sender sends a message, it may consist of text, number, images, etc., which are converted into bits and grouped into blocks to be transmitted, and often certain additional information called control information is also added to help the receiver interpret the data. For a successful communication to occur, the sender and receiver must agree upon certain rules called as the protocol. A protocol is defined as a set of rules that governs the data communication. A protocol defines what is to be communicated, how is to be communicated, when it is to be communicated. There are three key elements of a protocol. Number one, syntax. It means the structure or the format of the data. It is the arrangement of data in particular order. Number two, semantics. It is tells the meaning of each section of bits and indicates the interpretation of each section. It also tells what action or decision is to be taken based on the interpretation. Timing. It tells the sender about the readiness of the receiver to receive the data. It tells the sender at what rate the data should be sent to receiver to avoid overwhelming the receiver. Next, coming to for the better data communication system, standards in networking. Standards are necessary in networking to ensure interconnectivity and interoperability between various networking, hardware and software components. Without standards, we would have proprietary products creating isolated islands of users which cannot interconnect. The concept of standard provides guidelines to product manufacturers and vendors to ensure national and international interconnectivity. Data communication standards have been classified into two categories. They are de facto standards and de jure standards. De facto standards are the standards that have been traditionally used and mean by fact or by convention. These are the standards which are not approved by any organization or organized body but are adopted by widespread because of the general traditional usage following up. And when coming to the de jure standard, it means by law or by regulation. They are the standards legislated and approved by a body that is officially recognized. Standards are created by standard creation committees, forums and government regulation agencies. Examples of standard creation committees are International Organization for Standardization, International Telecommunications Union Telecommunications Standard, American National Standards Institute, Institute of Electrical and Electronics Engineers, Electronic Industry Associates. A standard organization, standards body, standards developing organization or standards setting organization is any organization whose primary activities are developing, coordinating, promulgating, revising, amending, reusing, reissuing, interpreting or otherwise producing technical standards that are intended to address the needs of some relatively wide base of affected adopters. And next, coming to the forums. And a forum or a message board is an online discussion site where people can hold conversations in the form of posted messages. They differ from chat rooms in that messages are often longer than one line of text and are at least temporarily archived. Depending on the access level of the user or the forum setup, a posted message might need to be approved by a moderator before it becomes feasible. Examples of the forums are ATM forum, MPLS forum, frame relay forums. And next, coming to the regulatory agencies. A regulatory agency is a public authority or government agency responsible for exercising autonomous authority over some area in a regulatory or supervisory capacity. An independent regulatory agency is a regulatory agency that is independent from other branches. A regulatory agency deals in the area of administrative, law, regulation or rule making, codifying and enforcing rules and regulations and imposing supervision or oversight for the benefit of the public at large. Example of a regulatory agency is Federal Communications Committee. And here we come to the end of the introduction to the data communication and networks. Thank you.